Let's see. I have such a hard problem. You're
Oh
gonna,
wow.
you're gonna
Okay.
be so frustrated today.
Do I sense some sarcasm?
Oh, just a little
Not really.
bit. Just a little bit. Let's see. All right,
Just a
let
little.
me go ahead and share my screen. I will send you the link through the chat. And I will invite you to my code editor if you'd like. There's 4 solutions for this one that I was able to find.
Solutions.
Yes, but the
Solutions is very good
the
word.
problem is one of those problems that make it a little challenging just because of the constraints where they're like, we need you to solve it with this time complexity and this space complexity. So they make it a little more challenging. There's a couple easier ways to do it, but we'll go over the problem first. I know you're limited for time today, so I won't even share any of my solutions. I'll just see kind of what comes to mind for you, give you a
Sure.
chance to type some code, um, and then we'll go
Yeah.
from there.
Deal.
Cool, cool. So
Sounds
I
fun.
sent you the live shared link in the chat, so feel free to hop in here.
I'm accessing right now. Okay.
Cool, cool.
Um.
And then, did you
You.
read the problem? Did you get the problem? I mean,
Yeah, I got a problem. I'm gonna read it
go
kind
ahead,
of quickly.
do your
You're
thing.
given two integer arrays, numbers one and two, sorted in a non-decreasing order. And two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. The final array should not be returned by the function, but instead stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements in the it's getting kind of complicated with the whole m plus n
I know.
bullshit. However, the first n elements know the elements that should be merged, and the last n elements are set to 0 and should be ignored. Number 2 has a length of... Okay, that doesn't really tell anything. Let's see the examples. Number 1, 1, 2, 3, 0, 0, 0. Nums 2, 2, 5, 6. And... Okay, and then... Yeah, okay. Mm, okay. So basically, the length of nums1 is m plus n. Okay.
Yes.
And
So in
then
the
you have
first example, 3 plus 3, because you have 3 elements with values in this one and 3 elements with values in this one, and they want you to replace the zeros with
okay.
these ones, basically.
Okay. I'll let you know what I think of it. Sure. So the way I see it, let's think about this first example here. You're telling me that length of nums1 equals m plus n, and the length of nums2 equals n. Fine. That's correct, right?
And yes.
Yes. So uh, we have the array here. It says 0, 0, 0, but the thing that I want to understand is that it's um it's merging the array, but the zeros are gone. That's what the part where I don't really understand.
Yeah, they
What?
basically want you to replace the zeros in nums1 with the actual values from nums2. Like in the example, num1, let's just say nums2 only had 2 elements, there would only be 2 zeros.
Okay.
If nums2 had 5 elements, then there would be 5 zeros.
Yeah,
So they just
because
want you to replace the zeros with the elements from nums2.
okay. So zeros and nums1 should always be replaced. Okay, I get it.
Yes, because you
Um.
they want you to return the nums1 variable.
Okay. So what I do is, I would let's do it here. I would iterate through nums1, starting from m plus n.
Mhm.
Sorry. Yeah, m3 plus n. Yeah, because that starts here. You don't even have to do a -1 or anything, because it's like 0, 1, 2, 3. So we start from here, and then you you replace not replace, but you assign uh nums1 with sorry, in the position plus n, m plus n plus I. So this is where you get your position, right? And then you get like nums2 I, something like this. So I starting 0 will be 2, but it's gonna be 3 here. I1 is gonna be 7 here. Sorry, 4 or 5 here, 5 here.
M
Yeah,
plus N
4.
would be
Yeah,
3,
4,
3
sorry.
plus 3. It would be actually, with this
Yeah.
example, it would be 6.
Yeah. It would be 6.
Yeah, because M is 3, N is 3.
Okay. So I guess m plus n doesn't really. Oh, I see. I get it. So yeah. So I don't start from I start from I. But the length should be less than m plus n, and then I just I can do, since I want to insert after m, I should take m plus I.
Mm-hmm.
I think that's kind of it. Let me try to do something before we run out of time here. So, for let I equal 0, I should be less than m plus n, and I increase. By the way, I haven't mentioned it, but I know that once they see an array that is sorted, that screams binary numbers, when binary search. So maybe there's a way of doing that too with that, but maybe not. I don't know. Anyway, so I'm gonna iterate through nums1. Am I doing that?
Mm-hmm.
No, yeah, I mean, can do that. Okay, so so let's see. Nums1, we wanna get m, which is like this position here. Yeah, plus I. And then we assign it for nums2 I. So that should be, so it starts 3 and 0, 4 and 1, 5 and 2, and that should be it.
Mm-hmm.
And then it runs out of space here because I wait, because it's gonna run for longer, right? Because I0 and this is 6.
Mm-hmm.
So I don't even why do we need m here? Maybe we need n because we only want to include 3 numbers.
Exactly.
Okay, so yeah, I'm thinking here.
I like that you're using N and M in here, because I did the same version, but instead I created another variable J for no reason. I like how you're just using the variables that already exist. So nice.
Oh, that's awesome. So yeah, let's just console log it to see what's going on. Let's console log the result just to see. There's no such thing here. Let's return nums1 just to see
Okay.
how it goes. Let me watch your screen. 1, 2, 3. It's not sorted though.
Exactly.
Okay. I guess we could use binary search for that, right? Or we could just do sort.
Yeah, we're not actually searching for something. We just need to sort it. Yep.
Yeah, can we just sort it? It's like too bad.
Yeah, basically.
Let's see again. 1, 2, 2, 3, 5, 6.
Yes.
Yeah, that seems to be the case. That's not too bad. But I know that this is O of n, of course.
Uh-huh.
And depends of the size of the input. We're not really taking any additional space, like except for the one we already have here. are we? Are we creating a new space here? Yeah,
Mm,
we're creating. No, we're
no.
not creating because we have two spaces. We're
Yep.
just merging it.
Hmm.
So it's like O1. Would you say O1 or O1?
It would be O of n with the for loop because you're only iterating over n, but it would be O of n log n with the sort.
Yeah, but what about space? I mean,
Space complexity O of 1.
okay. So this is O log n,
N log n.
n log n, which
Yes.
is it's worse than ON, right?
Yeah. Yep.
So okay, we can prove that by just doing a binary search if you want.
A binary search would be log n, but we're not
Well,
actually.
we don't need it really. I mean,
Yeah,
there are
yeah,
ways of doing sorting. Like, I need to be introduced to like quick sort, merge sort, and all that kind of stuff.
yeah. All
But
the
I'm
most
just
popular
familiar
sorts are.
this one with the built-in method. I'm sure there's a better way of doing it.
Yeah. Okay, so let's return this.
And return it.
You should be
Yeah. So
good
that's
to
one shot. Not bad for like
go.
10 minutes. Or
Nah,
something.
that's super solid. Yeah, you got it pretty quickly. Actually, this
I was gonna
solution,
work on
this solution is the brute force solution, so I'll just give you that
LeetCode,
right there.
of course. There must be some edge case I haven't thought of.
Nah, go ahead, test it out.
Here,
Paste it in.
I missed.
Paste it in there.
Hmm. Yeah, can you come up with an algorithm that runs O m plus n time? That seems to be the case, right?
Ah, so you are. Yep.
Oh,
Nums
O
one
n
sort.
plus n time. I'm not sure. I'm not sure what they mean by O m plus n.
And the sort is actually
I thought we did pretty well. So,
I think it. Let me
can
see
you hear me?
Yeah. Can you hear me?
Hello. I'm gonna change my headphones because it's giving me problems again. Just a moment. I can't hear you.
Yep.
Just a moment. I'm taking my earbuds because this stupid headphone jack is all weird.
Do your thing. Can you hear me?
Let me connect my device.
You.
Connecting in. Come on, device, please connect. Connect device. Why aren't you connecting? Come on. Oh.
Hey.
Yeah, sorry about that.
All good. You sound way clearer.
Okay, that's good.
Yeah. Is that like a headset with the microphone?
Yeah, I think there's audio for this earbud. I didn't know that. I thought sorry, there's microphone for this earbud. I didn't know that.
Oh, you sound way clearer, dude. That's awesome.
Oh, let me. Do you still hear me?
Yeah,
Do you still hear me?
perfectly.
Okay, I just I muted the phone that I have, which is like a Blue Yeti phone.
Okay, cool.
So I didn't know this was better. I'm gonna just use this from now on.
Yeah, this
Thanks
is
for
good.
the feedback.
For sure,
Okay,
for sure.
so brute force. So what you did here? Oh, mine
So
is brute force.
yeah, so yours was actually the brute force solution that I had, so I just put it in file too.
Oh, that's not good. Brute force is never really good, is it?
The built-in methods is the same efficiency as the one you had because it uses sort as well. So one of the two solutions that will work is the two pointers iterative or two pointers reverse. One is more efficient than the other. I'm not going to tell, unless you want me to tell you, I'm not going to tell you. I'll let you try to figure it out. But like you said, I believe you read, can you come up with an algorithm that's O of m plus n times? So the one you came up with was O of n log n. So not quite m plus n, but not bad either. Source not bad. Both the built-in methods and the brute force are n log n. This one is O of n time, but it's also O of n space. So you kind of lose space with this one. This one is O of n time and O of 1 space. So I'll give you a chance just to think through it if you want, just to challenge you a little bit.
Two pointers iterative.
Or just like whatever comes to mind, like regardless of the 2 pointers, iterative or reverse. Like, does anything come
Okay,
to
anything
mind?
else that
Building,
comes to mind? Sure.
just building on what you've already done.
Could I do something really stupid?
Yeah, the stupider the better.
Okay, let's see. Um, so nums1 slice m. I don't know if it's gonna slice everything's gonna slice 1, 2, 3. No, it should be. Mm. So what does it slice? Let's see, console log nums1. Can you show me what's slicing? Because I don't remember like
Yeah.
inclusive, exclusive, and all that. I always get
No.
confused with exclusive.
Oops. There you go.
Okay,
So slice is actually not modifying it in place. You'll actually have to do like nums1 equals.
no, you're right. Okay,
There you go. So 0. So it starts at m
okay, we don't want that.
to the m.
Mm. So I want to actually retain the other stuff,
Mm-hmm.
not the zeros. Shit.
So
Yeah.
you could pass in one argument to slice. If you pass in one argument, that's going to be the element that it starts at, and it's going to slice until the end of the array. Or you could pass in two elements. One's going to be the starting element, and one's going to be the ending element.
Okay, I guess nums1 dot length, I guess. Not sure if it works.
Well, that's already what it's doing. You're not changing anything with that. It's already going from m to.
Yeah, I really need to practice slice. 'Cause I always forget
M
what
is
it
correct, but m is the second argument.
Okay.
You're missing the first argument.
Uh,
From what to m?
from what to
Yeah.
M to
From
M?
what element to m?
0, 1, 2, 3. So yeah, 3. Which
M is the third element, right?
yeah.
So you want to slice up until m, but where do you want to start?
Okay. Yeah, that's silly me, sorry.
There you go.
Okay, so let's see if it's correct.
Yep.
Okay, cool. So, okay, so I'm gonna do something that's probably really stupid. Um, I'm just going to do nums1 equals nums1, no, nums2 sort, and then we return nums1. That's probably not efficient at all.
No, that should work.
Let's see if it works.
Yep.
It's sorted as it should be, right?
Yep. It is sorted.
So, we do create a new array, which is the size of m plus n, right?
A new array.
Yeah. Oh no, we don't. We modified the array. Yeah, you're
Yep.
right.
Yep.
So this is n log n. So okay, so this is n log n.
This is, yes, n log n because of the sort.
So that's still not m plus m plus n. It still
No.
sucks, right?
It doesn't suck. It's good, but they just challenge you. I'm gonna post it right there because that is the built-in method solution.
But that's worse than n or not?
These two are both the same. Brute force and the built-in methods are both the
No,
same.
but I mean, is n log n worse than n?
Yeah. Yep.
Okay. What I don't understand.
N log n
I
just
want-
means n log n means this. So where binary search is gonna take the number of elements and it's gonna be like the square root basically. N log n is the first iteration you would go over 6 times. Second iteration you go over 5 times. The third iteration you go over 4 times. The third iteration you go. So you're removing one element every single time. Just doing it over. It's basically n squared, but like optimized, I guess you could call it.
What I don't understand, and maybe you know the answer to this, is why the hell with so many kinds of sorts, such as quick sort, merge sort, and stuff like that, why don't they change it to a more efficient algorithm for the sort built-in method?
I don't know any O of n algorithms. The best ones I know are O of n log n. I know a bunch that are O of n squared too, but that's not better than n log n.
Okay, I didn't know
Yeah.
that. I thought there may be alternatives to that. So okay, we have like 5 minutes if you want to show me the way the lead code wants me to do. That'd be great.
Yeah, I'll go ahead and skip number 3. We'll move straight to number 4. So I'll show you.
Yeah.
Basically, we have. Actually, I did write some notes down here. So basically, we have. We'll just do this example here. We're gonna have 3 pointers. We're gonna do let p1 equals m minus 1. Oops. We're gonna do let p2 equals n minus 1. And then we're going to let insert or place, or I'll just call it insert because that's the position we're going to actually be inserting values, is m plus n minus 1. So you could see, I guess we'll call that one insert. So we have P1 starting at the m position. We have P2 starting at the n position of our second array. And then we'll basically just iterate. So while P1 is greater than or equal to 0 and P2 is greater than or equal to 0. So once one of these move outside the bounds of the arrays, we're going to break out of this while loop. We're going to check if nums1 P1 is greater than nums2 P2. So if this value here is greater than this value here, it's not. This one, nums2 P2 is actually greater, so we'll go to else, and we'll say nums1 insert nums1 insert equals nums2 P2. So we're taking that value from nums2, the 6, we're placing that there. And then we're moving P2 down 1. We're moving I down 1. So we'll do P2 minus minus, insert minus minus. And then we do it again. We start over. If nums1 P1, so the 3, is greater than nums2 P2, which it's not. We actually have 5 now. So we'll take that 5. Nums2 P2, the value is 5. We'll place it at nums1 insert. So we'll place the 5 right there. We'll move insert down. We'll move P2 down. Right here and right here. And then we'll do it again. If nums1 P1 is greater than nums2 P2, which here it is. So nums1 P1 is 3. Nums2 P2 is 2. So in this case, we'll do nums1 P1 or nums1 insert equals nums1 P1. So we'll take that 3, we'll store it right here, we'll move P1 down, and we'll move insert down. So we can do P1 minus minus, insert minus minus. Same thing right here. If nums1 P1 is greater than nums2 P2, it's not. It's actually equal. So we'll take this last P2. We'll store that there. We'll decrease the P2, which is basically going to push it outside the bounds of the array. We will decrease insert. Well, now P2 is outside the bounds. So insert would actually be here, but that doesn't matter anymore. There's only one condition. So if we break out of the loop where P2 leaves the bounds, then we know that we reach the end and nums1 is already sorted. So anything left in nums1 is already sorted. We don't have to worry about it. But if P1 exits the loop first, we still need to fill up the rest of nums1 with the lower values from nums2. So we would do while P2 is greater than or equal to 0. Then we basically just run this code until P2 exits. And then we just return nums1.
So this is just like an edge case in case that nums1 has less elements than nums2, right?
In
Or not?
case, in
Or does?
case, yeah, in case because if P1 exits the bounds of the nums1 array first, that means
Mhm.
that nums2 still has values that are lower than the ones that were in the like 1 and 0 position of,
Yeah, yeah.
so we still have to, wherever I is, like if I is on 3, we need to take this, put that in 3, take this, put that in 1, take this, put that in 0, like we need to finish it off. But if
Yeah.
P2 exits first, then nums1 is already sorted, so we know we don't have to do anything in that case.
Yeah, I understand. So, but it's not really about the length. It's about if there's anything else to be sorted.
Exactly. Exactly. Yep.
Wow, this is really sophisticated. Like, what kind of sorting is that?
This is this actually isn't, I wouldn't consider this really a sorting algorithm. I would consider just a pointer algorithm.
Okay.
Yeah, using pointers to fill the 0 spots, but from reverse. Yeah, so I
Um.
called it 2 pointer reverse
Okay.
and O of 1
What would
space.
what would be the most efficient sorting algorithm for this problem? Like of all the existing ones
Um,
that we haven't learned here yet.
Sorting algorithm.
Yeah, there are a bunch of sorting algorithms, right?
Yeah,
Like quick sort, merge sort, or
yeah,
bubble
yeah,
sort.
yeah.
Like, if you had to implement one of them, I know we haven't been introduced to them. Hopefully, we'll be able to learn those soon. But which one would you say is like the ideal one for this?
I would say, based off my sorting knowledge, I would say no sorting algorithm is really good. If
Really? Wow.
Yeah, if you don't have to use a sorting algorithm, you don't want to use it. O of n is gonna be any sorting algorithm.
Okay.
Yeah, the only yeah, as far as I know, there's no sorting algorithm better than O of n log n.
Okay.
Yeah,
Cool. So this is O of n log n.
this is O of n.
Okay. So
Yeah,
this is even better.
this is linear. Yep.
Sorry, I have kind of a cough here.
No, you're good, man. Do you have time to see the other algorithm, or you gotta slide out?
Nah, unfortunately, no, I gotta go, man.
All right, no sweat.
Thanks for showing. I was glad I was able to have two solutions, even if one of them was weird, but it was actually the same efficiency, so I don't know.
Yeah, no, those are the ones you kind of just like. I feel like everyone kind of just goes to these ones first. That's why they challenged us with this m plus n.
Okay, are you putting these on YouTube later? Because I want to watch like the other solutions.
Yeah, I'll go ahead and just like break down this solution and post it, and then I'll add it to YouTube so you can watch the whole thing.
Awesome. Thanks, man. I gotta go now.
Yeah,
Thanks.
for sure. Have a good one,
Bye,
man.
John.
Score a goal
Bye,
for me.
Chin. Thank you.
See you,
See ya.
man.
What's up, John?
Hey, what's going on?
Not much, not much. Did you where were we when you popped in?
You guys are just finishing up. I mean, I probably got in there maybe 3 or 4 minutes ago, so nothing. Wasn't able to really see too much. I guess I got to see you finish that wild loop, but not really at the start of anything. Kind of know
Okay.
what it was even
Gotcha,
about.
gotcha. I could go over what the problem is and kind of walk through a couple if you want.
Yeah, no, perfect.
I posted the problem in the chat, so if you want to go ahead and it's called merge sorted array. Let me know when you pull it open in LeetCode.
All right, I got it here. Yep.
Cool.
Pull it up.
Cool. So let's see. So we're given two arrays, nums1 and nums2, sorted in non-decreasing order, so increasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. So you could see our nums1 is 1, 2, 3, 0, 0, 0, and m is 3. The reason why m is 3, even though there's 6 elements in nums1, is because only 3 of the elements actually have values. These other 3 are supposed to be replaced. You can see nums2 has 3 values, n equals 3, so this matches up pretty well. What we want to do here is we want to take these values from nums2 and replace the zeros with the values from nums2, basically. So merge nums1 and nums2 into a single array sorted in non-decreasing order. So they're both already in increasing order. So we just want to keep them in increasing order. The final sorted array should not be returned by the function, but instead be stored inside of the array nums1. So it doesn't want us to create any new arrays, any new space. To accommodate this, nums1 has a length of n plus n. So like I said, we have m equals 3, but we actually have 6. So 6 is because 3 plus 3. Where the first m elements denote the elements that should be merged. So these 3 should be merged. And the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So you can see in this example, we have our first element, first array, nums1. We have our second array, nums2. The valuable elements, there's 3 in nums1. The valuable elements here, there's 3 in nums2. And we want to connect both of these arrays. We want to take the values from nums1, place them, or from nums2, place them in nums1. The arrays we are merging are 1, 2, 3, and 2, 5, 6. The result of the merge is 1, 2, 2, 3, 5, 6, with the underlying elements coming from nums1. So you can see index 0, 1, and 3 should be from nums1, and 2, 5, 6 should be from nums2. So the length of nums1 array is going to be m plus n. The length of nums2 is going to be n. M and n are going to be anywhere from 0 to 200, so small. M plus n is going to be anywhere from 1 to 200, so that means that nums1 is always going to have at least one element, and a maximum is going to have 200 elements. And then the value of each element inside of both of the arrays is going to be anywhere from, I think that's 10 billion, negative 10 billion to positive 10 billion. The challenge here is this last line, follow up. Can you come up with an algorithm that runs in O of m plus n time? That's the challenging thing. This is the one Daniel came up with first. He was kind of like, let's just start at the m position, so at the 3 position in nums1. So nums1 m plus I during the first iteration would be 3, because it'd be 3 plus 0, and nums2 0. So you take this 2, you'd store it in m plus 0, so 3, and then you iterate, you increment I, so I would now equal 1, so m would still be 3, I would be 1, I in nums2 would be 1, so you take nums2I, so this right here, and you'd store it in nums1 m plus I, so 3 plus 1, so 0, 1, 2, 3, 4. And then one more time you would increment I would equal 2, so you take nums2 2, which is this 6, then you would store it in nums1 m plus I, so 3 plus 2, that's the 5th element here, you'd store that 6 in there. And then you have the array built, but you still have to have it sorted. And this sort method right here is O of n log n, so that's worse than that's worse than what they're asking for. So this solution unfortunately wasn't the best. And then I'll show you one other solution he had, and then we can kind of walk through these other solutions if you want. Another one is he just sliced the front of nums1 array. So this slice is slicing from position 0, so just before the 1 to position m. So it's taking the 1, 2, 3, it's creating a new array and storing that. So it's basically eliminating the zeros, just getting rid of them entirely. Then he is concatenating the nums1 array, which it now consists of 1, 2, 3, and the nums2 array, which is 2, 5, 6, creating a new array with both of them and sorting them, storing it in nums1 and just returning nums1. This one too is O of n log n, so it's not really the most efficient. Do you have any thoughts on this problem or any ideas of your own on how to solve it besides David's?
No, I like that second solution that he had. Yeah, that one.
Yeah, it's the simplest.
But you know, I'm not the greatest as far as kind of getting or finding the best solutions to minimize, I guess, kind of the O of n plus n. So for me, I just been like, when I work in the LeetCode, it's like just figuring out how to solve it.
Yeah.
You know, it's like my first step. So
Yep.
I probably would have, but yeah, no.
So even with this one here, I think I would have, let me see if this works. Splice, I think if we splice 0 to m, that'll modify this in place so we don't have to like do that storing operation. And then if we did nums1 dot concat nums2, I think that would work too. That might do it in place, I believe, too. And then we could do a sort here. Let me see if that works. Nope. Let's see. Nums1 equals 2, 5, 6. Splice 0 to m. There we go. All right. Yeah, that seems a little cleaner, but they both work. These are just using built-in methods. So we'll go over to this solution. I'll show you this one. This one still isn't exactly what they're looking for. So in this one, we're going to take this array. We're going to take this array. And basically what I'm going to do is I'm going to create a left pointer equals 0. Or let's just call it 1 pointer equals 0. A 2 pointer equals 0. And a I guess we could owe it. That should be good right there. So we have our 1 pointer and our 2 pointer. So we're going to use these 2 pointers to target the elements here. So we would do we would basically just say we actually need a new array for this one. So this one would create extra space. So we'll build a new array. We'll compare these two. Which one's bigger? Nums1 with the 1 pointer, so the 1 value, or nums2 with the 2 pointer. We'll just call this P2 and P1 to make it a little more clear. Pointer 1 and pointer 2. So which one's bigger, or which one's smaller, 1 or 2? 1. So we'll push that onto this array, and we'll increment this. Then we'll compare them again. What's bigger, this one or this one? Doesn't really matter, both of them. So we'll increment this. What's bigger, 2 or 5? 5 is bigger, so we'll add the 2. Increment this. What's smaller, 3 or 5? 3. So we'll add that and increment this. Now we know that we're outside the bounds. We passed M, basically. P1 equals M. It equals 3. So we could break out of that while loop. And then we would check to see if there's any left in here. Any left in here. There is still some left in here. P2 is only equal to 1. And this equals 3. So we would take this 5. Add that. Increment that. Take the 6. Add that. Increment that. And now we're outside the bounds. So we would just store this value inside nums1 and return that. So the problem with this one is that we're actually creating a brand new array to build a sorted list without having to do the sort. So this algorithm is actually O of n time complexity and O of n space complexity, or technically O of m plus n and O of m plus n. Let me see. Can you come up with an algorithm that runs in O of m plus n time? All right, so this one actually works based on their requirements. So this is O of m plus n time.
And how can you tell that?
Because, all right, so if this right here is m, right? There's 3 here.
Right. Yep.
And this is n, so this is also 3. But maybe it's possible that this has more. In this case, n would be 5. Because you have 5 total, right?
Right.
And m would be 3. So if I have to do an operation for each one of the m elements and each one of the n elements, then that would be O of n plus m. Let's do it with just this right here. Let's just say we have one array and there's n elements, right?
Yeah.
N equals 6. Let's forget about just the problem at all. Let's just say we're thinking about a different problem. We have this array right here, and we have the length of this array is 6. So there's some algorithms where, let me add a couple more to this actually. Oops. And this is 4. All right, so we have 9. Now, if I have to iterate over this array and check every element, then this is an O of n algorithm. So O of n. And this is because I actually have to iterate over the whole array. Now, there's an algorithm where I actually have to iterate over the array and check every element. And then I need to iterate and check all 9. And then on the next iteration, I need to check 8. And then on the next iteration, I need to check 7. And then the next iteration, I need to check 6, then 5, then 4, and it's slowly decreasing. That is O of n log n. And then like binary search, where I'm checking, I have like pointers. I have like a left pointer, a mid pointer, and a right pointer, where I take this value, so 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus the left pointer, which is 0, divided by 2, which is 4. So I have this middle position, and I check for 5. And then I see, like, let's just say I'm looking for 8. So I check the middle element, and the middle element is less than 8. So I know I have to move this m element to the right. So I move the L element, the L element to where the M element was. And now instead of doing 8 minus 0, because the L was on 0 before, now I do 8 plus 4, so 12 divided by 2. 12 divided by 2 is 6. So now I move the M to the 6 position, and I would check this element, and since this 8 is the one I'm looking for, then I would find this algorithm where I'm looking for the middle one, And then if the middle one's not the one I'm looking for, then I look for the next middle one, because if it's sorted, I know which side it's on at least. If I'm looking for a 2 and the first element I see is a 5, I know the 5 that I'm pointing at is greater than the 2, and so I know that the element I'm looking for is on the left. But if the element I'm looking for is an 8 and I land on the 5 as the middle one, I know the element I'm looking for is on the right. So by moving the left element to the right, then I know that now I just have a smaller array that I could work with and look at the middle. And if I keep looking at the middle, that is O of log n. So n log n is going over the array 1 full time, then 1 full time minus 1, then 1 full time minus 2, then 1 full time minus 3, then 1 full time minus 4. That's n log n. O of n is just going over at 1 time. So checking each element just 1 time. And log n is if there's 8 elements, the most you're ever going to check this is 2 to the power of how do you explain that? So like 2 to the power of 4, 2 times 2, or 2 to the power of 3, 2 times 2 times 2. The most I'm ever going to do in an O of log n problem, if I have 8 elements, is 3. So one operation here, one operation here, and then if 8 wasn't the one I'm looking for and it was actually 6 or 11, that would have been the third operation.
Yeah, I think I've seen, because I've been trying to, I got to get back to it, but I was watching a little, like, the Harvard algorithm course, and he kind of explained it, like, if you were looking for, like, a word in the dictionary, like, you would divide it in half, and you're like, oh, okay, it's, you know, and it's, like, just a faster way to be able to sort it, or, you know, or find, like, a specific thing instead of, like, going through every single thing.
Yeah.
You just look and say, is it on the left or the right? Yeah, okay, so that makes sense.
Yep, exactly.
Okay.
And then there's also, you never want your algorithm to be O of n squared. But some graph algorithms, like this is really the best you can get.
Yeah.
But that would be like, for each element, you iterate over the whole array. So for the first element, iterate over every element. For the second element, iterate over every element. For the third element, iterate over every element. That's O of n squared.
And I would assume, like, I mean, that would be like a longer loading time for something if it.
Yes. You don't really ever want O of n squared.
Yeah.
You don't really ever want O of n log n either. Like, you really want O of n or log n, honestly.
Yeah.
At least, like, the big tech companies, they're looking for this sort of stuff, you know?
Yeah. Okay.
Yeah, so that's that solution. I'll go ahead and just write out the code. So we'll say let P1 equals 0. Let P2 equals 0. While nums1 P1 is greater than or equal to 0. And nums2 P2 is greater than or equal to 0. So this is just saying, as long as oh wait, actually is in this one it's less than or equal to m. This one is less than or equal to n. Yeah, my bad. This is basically saying while this pointer is within the valid number range, once it moves to the zeros, you're outside the range, and so you would break out of the loop. This one, nums2 P2 is less than n. You're saying like P2 is within the range of the array, so it's either on 2, 5, or 6. Once it goes outside the range, then it would break right out of this loop. So you actually, so while P1 is less than m, or P2 is less than, all right, so we check and we say if nums1 P1 is less than nums2 P2, then store we need a new array too, so let new array equals just empty array. So we'll do new array dot push. If nums1 is lower, we'll push nums1 p1, and we'll increment p1, else new array dot push nums2 p2, increment p2, and then either this p1 is going to go past m first, or this p2 is going to go past n first, but even still, we'll do checks for each one of them. So while p1 is less than m, new array dot push nums1 p1, p1 plus plus, or while p2 is less than n, new array dot push nums2 p2, and then p2 plus plus. So when we break out of this first array, either p1 or p2 has passed m or n. So either p1 has passed m or p2 has reached n. So the reason why we do these checks and both of these checks is because, let's just say p1 is the one that moved to the m position here, and p2 is still right here. When we go and say while p1 is less than m, this isn't going to run. This is just going to skip because p1 is already passed. So it's only going to worry about this. So it'll take care of the last element in nums2. But let's just say p2 passes and we break out of this main loop, and p1 is still less, p1's value is 0 and m's value is 3, then we'll push 1, we'll push 2, we'll push 3, and then p1 will be equal to m, and we'll break out of that loop. p2 already finished from this loop, and in this case we would just we would set nums1 equals new array, because it wants us to return it in nums1 for some reason. Nums1, or instead of just storing it directly, which I don't think I would do this, I'll just do let I equals 0 while I is less than m plus n minus 1. So basically the full original length of nums1. Then I would take new array I and store that value in nums1 I, and then we'd end up with nums1 with all the values from new array stored in it. Do you have any questions there? Does this all make sense to you? Let me know.
Yeah. I know initially the while loop, kind of once I got to the check, we're not gonna say I got lost, but so the initial while loop made sense, because while that number was you're basically going through both. If I'm not, or if I'm getting this right, so you make the new array, then you get to that while loop, and you're essentially saying you're going through both arrays, P1 and P2, and you're essentially putting whichever of the two is lower, the lower number, into that new array. You're pushing that into that new array.
Yep.
Once we get to the next two while loops, that is, I'm not gonna say I got lost there, but so is that just checking? You said it wouldn't run. I guess could you re-explain that part?
Yeah, so let me go ahead and just, so in the beginning we're starting both of them at the 0 position, right?
Right.
So we're only running this while loop while P1 is less than M. M in this case is 3, right?
Yep.
So it'd be pointing there. And while P2 is less than N, which N in this example is also 3, because length of 3.
Yep.
If at any point P1 passes into the M realm, 3 or more, or P2 passes into the outside the bounds of the array, so N or greater, then we break out of this loop. We know for sure that either P1 is going to hit M first or P2 is going to hit N first. But regardless, there's still going to be one of them that are inside the array. Right?
Right, because one's going to be moving. Yeah. Okay.
Yeah, so 1 is lower here, so we'd move it here. 2 is... They're the same. So 2 is lower than 5, so we'd store that one, move here. 3 is lower than 5, so we store that. Now we're outside. Now we're breaking from this loop. But we still have 2. We still have 2 here.
Right.
We have 5 and 6 here. So this while loop is just going to say while P2 is less than N. P2 is currently valued at 1. N is 3. So while P2 is less than N, then we'll push this 5. We'll push this 6, P2. Now we'll break out of this loop and we have the new array completely built.
Gotcha.
Let's say that this was 8, this was 7, and then we did the same thing. 1 is lower, so you move to that 7. But now 2 is lower, so you move to that 5. 5 is lower, so you move to the 6. And now you're outside the bounds of the array, but it was 2 that broke out of the loop first. So one of them are always going to be breaking out of here first. It's either going to be P1 or P2. On this one, P2 broke out first. So in this case, we wouldn't be running the second loop. We'd run this first while loop so we could complete P1. So we'd store this 7 in the new array, increase P1. We'd store that 8 in the new array, increase P1. Now P1 is equal to M. It's not less than, it's equal to. And so we break out of this while loop. P2 is already equal to N, so you never even enter this while loop. And then you take all the values from new array and just start from 0, 1, 2, 3, 4, 5 and iterate over the new array, storing all of its values in nums1 since the problem asks for nums1.
Okay. No, that makes sense.
Cool.
That makes sense.
There is, so this other solution, I'm going to go ahead and delete this stuff here. I already went over this solution. It's in the YouTube video.
Okay.
So I'm going to say this solution here, it's very similar to the 2 pointers iterative. The only difference is we don't create a new array for this. I'll go ahead and just explain it briefly for you so you could see the difference between it. And so same thing, pointers. So P1 starting here, or P1 starting here, P2 starting here, and then we have an insert, or let's just use I, starting on the last. So we have our insert pointer pointing to the end of nums1. And instead of iterating from 0 and 0 to M and N, we're starting from M minus 1 in nums array, so 3 minus 1, which is the 2 position, and N minus 1, which is the 2 position here. And we're comparing these. So which one's greater? This time we're checking for which one's greater. It's nums2 P2. So we take that 6, we store it there, and then we move P2 down. Same thing. What's greater? Nums1 P1 or nums2 P2. 5 is greater. Oops. So we decrement that. We store the 5 there. We decrement P2, and we also decrement our insert pointer. The insert is just keeping track of where we're inserting next. Now we check, we have what's greater, nums1 P1 or nums2 P2. 3 is greater, so we take that 3. We decrement P1. We check again, and we decrement the I. So you can see every time we replace one of the values, we decrement either P1 and the insert pointer or P2 and the insert pointer. So in this one, if nums1 p1 is less than nums2 p2, they're actually the same. So we'll take p2, store that there, and then p2 now moves outside the bounds of the array, but to the left side. And so since the only elements that are left are elements from nums1, and we know that nums1 is already sorted, we know that this is already in order. So we're good right here. We would break out of here. The only check we do is if p2 is still greater. So let's say this was -2, for example. Then we would take this 2, store it here. We decrement p1 and our insert pointer. We would compare nums1 p1, which is 1, to nums2 p2, which is -2. So we take this 1, we store it where our insert pointer is, and then now we'd see that p1 moved outside the bounds of p2. I mean, p1 moved outside the bounds of the nums1 array, and p2 still has a value here. So if p1 exits the bounds of the nums1 array, we actually still have to add values from p2 to the nums1 array. But if p2 exits the bounds of nums2 first, we don't have to do anything because p1 is already sorted. It's in order, and all of the values that we would be inserting with the insert array are already in nums1 array. So the only time we ever do anything after our main while loop is if p2 still has values. In this case, while p2 is greater than or equal to 0, so in this case p2 is equal to 0, then we take nums2 p2, that -1, we'd store it in the nums1 insert. So right here, since the insert element is equal to 0, put -2, decrease p2, so now it's outside the bounds, decrease that, which doesn't really matter, and we'd return nums1, and you're returning nums1 in order. In this case, this is O of m plus n, because you're iterating over all the elements of the nums1 array, which is m. You're iterating all the elements of nums2, or n. So O of m plus n. Time complexity, and O of 1 space complexity, because we're not adding anything. So this is actually, both of these work. The 2-pointer that we did, this works because the only thing they're looking for is O of m plus n time complexity. They never say anything about space complexity. The space complexity in this problem right here, the one we did previously, is O of n, because we're creating this new array with m plus n elements inside of it. This one, we don't actually have to create a new array. We just iterate strategically, reverse instead of from the front. So we're able to rebuild the nums1 array in a way that we only have to iterate O of n time complexity. So, and I explained it again. Like I said, I'm gonna post it on YouTube. So, do you have any questions on this one here?
No. No, that makes sense.
Makes sense. Okay, cool. Yeah. So the 2-pointer is a very, very useful approach for sure. I'm actually working on an algorithm right now. It's called Maneker's algorithm. It's a string problem, and this thing I'm using, I have an I pointer, I have an M pointer, which is like the mirror of the I have a C pointer, keeping track of the center, and then I have an R pointer, like the right boundary of the string. So there's 4 pointers, and then it's just like a whole nother story, dude. But you'll see. Is get familiar with like 2-pointer problems, and then we'll start diving into like 3-4 pointer when you're ready. You'll like it though.
Okay.
Yeah. This other one I'm working on, man, they would never even ask you for it unless you were specifically interviewing for like a position where you build algorithms or something. So, but if you do know something like that, like let's just say you really trying to get into a big company like Google, if you came into an interview and you showed them like, hey, the brute force solutions, and then you showed them another like the expand from center solution, which is another efficient but not the best, and then you showed them like a named algorithm, you'd probably get the job over anyone else, you know. So it's tough. You'd be staring at the screen for like 4 hours just trying to wrap your head around it, but it pays off in the long run. And you said you're not in tech yet, but you're looking for a job right now, right?
Yeah.
Nice. Are you interviewing, just filling out applications, or how's it going?
Just filling out applications. You know, I think, you know, the few that I've gotten, the algorithm challenges is where I've been stumped. And it's just being comfortable enough to get through that aspect of it. And that's what kind of led me to here. It's like, all right, I got to get stronger at the algorithms. You know, I have a few projects, but when it comes to like an algorithm challenge, it's a little nerve-wracking, I guess.
Yeah, I hear you. Do you how many interviews have you done so far?
I have done like gone through that algorithm stage, or just only one. Only one. I've gotten to the algorithms twice. Not every job is asked for an algorithm. Some just, you know, want to see like projects and things like that. So, but yeah, only one with the algorithm. But that's you know, a little bit tougher for me.
Yeah, you'll get it. It's just practice at the end of the day.
Yeah, and that was me, and that was the thing. It was kind of like I thought that I knew enough to be able to do it. And even sometimes, like when you look at it like this, and even with LeetCode, and then sometimes they'll ask you for hacker rank, but it looks different, and it kind of makes it a little bit tougher to do it from hacker rank. So, I don't know. It was something small, but I figured that I'm like, all right, the more that you know these algorithms, because that seems to be what probably people that have gone to school for computer science are probably stronger at. And that'll kind of help level the playing field for me if it's like, all right, you know, obviously I don't need to be perfect at it, but enough to be able to handle most easy problems, I guess. Just knowing, all right, how to work through it. Like the more that I'm seeing them, like even when you went through that, you know, when you went through the first problem that we went through, and then I'm like, all right, I'm able to look at it, and even how you put the example at the bottom and you move P1 over and then you move P2 over. Like if I do stuff like that, I think it helps. You know, I guess it's no different than like somebody that's learning math if they like literally like do long division instead of just using the
yeah.
You know, it's like literally walk through it. I think I have to do stuff like that.
Yeah,
you know,
same.
And it helps me understand it better, because that helped me, because it's like, okay, that's what that means, is that it's moving over. Now this moves over, and then you move it's literally like long division, like carry the 1. Now how many times is 4 going to this, you know?
Yeah. But you have to do it like that, because if you don't do it like that, then you're just memorizing code, which is like, you have to understand the mechanics.
Yep.
You have to. It's just going to make everything so much easier. That's what really makes the interviews and solving problems easy. There's so many problems out there, man, that they're going to throw you a curveball. You're going to come across one that like you just haven't memorized, you know? And if
that's what it was. It was like, I'm like, oh my God, like I don't know, but if you're able to, if you just know how to do division, not okay, I know how to do 4, 40 divided by 4. but they just did 80 divided by 4. Oh my God, that looks totally different than 40. You
You
know,
know, yeah, yeah.
but if you like, I mean, that's 100% what you just said. Like, if I know the mechanics of it, if I know, like, okay, it doesn't matter what you throw at me, I know how to work through this by working it out. Let me pull out the long division, and I'm gonna go piece by piece right in front of them, and it won't matter which problem you throw. I still know how to walk through it.
Yeah,
And I think
exactly.
that's, as we're doing these, that's helping me get, learning in depth. Because even when you look at the problems on LeetCode, you're reading it opposed to somebody teaching it like now. You know what I'm saying? So like you're reading the solution. It's like, okay, you walk through it, but if you got somebody walking through it, like I said, I guess that's the element of them having a teacher in college, where it's like a teacher can talk through it. So this helps.
Cool, cool.
Big time.
That's good to hear. Yeah, I used to do just like one algorithm a night too, and that was easier for me and just for everybody to digest too. But it's like I would rather put in a little bit of extra time and come up with multiple different solutions, because it's just so much more helpful, man. Because you do this problem and then you're going to encounter another problem and you're going to be like, these 4 solutions right here, built-in methods, brute force, 2 pointers starting from the front, 2 pointers starting from the reverse with an extra pointer for the end. Like, you start thinking about all these different solutions that you've used in the past, and the more solutions that you use on one problem, the easier it's going to be to apply one of these solutions to another problem, and even just think through like a repertoire of solutions that you have, like formulas that you have and you're ready, locked and loaded to go, And the thing is, a lot of the time the problems are different, so you'd be like, I could use this 2 pointers from reverse for a new problem, but I have to change it. Like, I have to change, I'm using these variables instead of this variable, and I actually do need to create an array for this one, so it's going to be O of n space too. Like, even though this one that I just showed you was O of 1 space, there's still a lot of them are very similar, but you just have to change them in very small ways. And if you have this repertoire of different solutions, it's worth the time putting into it, honestly, for me and everybody involved. So it's nice.
Yeah.
For sure. What would you say if you wanted to improve these get-togethers? I'm always looking for feedback to make this stuff better. Like, what's the smallest thing you think that I could do that would make the greatest positive difference, you think?
No, I mean, to be completely honest, like I said, so far it's been great, because even when I'm able to get here earlier, and we've been able to kind of give it a shot ourselves first, and then walk through it. I mean, no, it's been helpful. I think that even if there were, I don't know. I mean, I think it's fine right now. I guess that's the best way to explain it.
Cool.
I don't know if there's any additional things you can learn, or if there's like a new methods that can be thrown into certain problems. Like, oh, you can use this. But like I said, it's just learning. I think what you said initially, and I don't know how much time, even if it was like you're able to do 2 problems a night, but it's going through multiple thought processes through even just one problem. Because like you said, if I know how to break this down multiple ways, when I get to a new problem, I know 4 ways to break down any problem. So I just got to know which one to use, which one I'm more comfortable using, or which one makes the most sense in this situation. So I think it's just, finding different ways to even solve the same thing, or at least, and I don't know, maybe I'm repeating the same stuff, but
Nah. It all makes sense. Yeah, totally. And if you think of anything, if anything else comes to mind, definitely just reach out. Let me know.
Okay.
Yeah.
Sounds good.
For sure, man. Do you have any questions before we hop off, or anything else?
No, I appreciate it.
Yeah, for sure.
Right.
Enjoy the rest of your night. See ya.
You too.